Hello, everyone. My name is Sarath Gongunta. I am a switching technical marketing engineer. Today, we're going to discuss about the enhancement to ARP suppression to support L2V types. So as part of this session, we'll go over overview, use cases, configuration, guidance and caveats, and troubleshooting, and finally a quick demo on this one. So we know that ARP suppression is already supported. It started support in 10.06. This is to reduce flooding or ARP requests, but it requires SVIs for it to be enabled on the L2 VLANs. That means if an SVI is configured, ARP suppression is enabled for L2 VLANs, and the ARP suppression is not possible if it is not configured for them. So with this new feature, ARP suppression extended, ARP suppression is supported for L2 VLANs too. The new command is ARP suppression extended, as you see here. This for IPv4, and this is under the EVPN context. And similarly for the IPv6, it is ND suppression extended. These commands support the suppression on the L2 VLANs, as we talked, without the active gateway SVIs. EVPN fetch these L2 ARP learns and publish the same to remote VTEPs via the route type 2. Now let's talk about some of the advantages of this feature. In general, VXLAN ARP suppression. It will no longer, with this feature, it no longer flood the VXLAN L2 fabric, and ARP responses are local, as we know, using cached MAC IP bindings. This also improves the scalability, and we see less ARP bump traffic. It enhances the convergence speed and also improves network efficiency. This feature reduces the flooding of host IPv4 and IPv6 neighbor discovery messages, which is ND messages in the VXLAN overlay network, which results in more efficient use of the underlay network. So basically, this new command, ARP suppression extended, provides a complete existing functionality of ARP suppression. Additionally, it will now provide ARP suppression support for L2 VLANs. As you can see here, ARP suppression extended is support on 8325 and CX 10K on version 10.16 So these two platforms, ASIC support port-based steal, so that the steal happens at the port level. I will talk on this with a small example. So if VLAN 10 is under EVPN context and VLAN 20 is not under EVPN context, and these two VLANs are on this interface, let's say 111. So ARP or ND packets are stolen for both VLAN 10 and VLAN 20, even though the VLAN 20 doesn't support suppression. But there won't be any suppression functionality on the VLAN 20, and NDMD module will do the forwarding as generic. So the ARP suppression extended is currently implemented on these two platforms because of the ASIC limitations on other platforms, but there is a plan to extend to other platforms in the future releases. Let's discuss the use cases and the flow details here. In the first topology, as you see, there is no ARP suppression config. So you see there's a request from the VM1 for VM5, and VTEP broadcasts the information, and same way the VM5 responds back with a reply, and then the VTEP again floods the response back to the VM1. And there is no suppression entry created in this case. So now let's talk about the second topology with suppression configuration enabled. So when VM1 sends an ARP request to obtain the MAC address of the VM5 here, VTEP1 creates a suppression entry here. And then when VM5 sends a response to VM1, VM1 again creates a suppression entry for VM5. So when VM6 wants to contact the VM1, this time, since there is a suppression entry already, so the VTEP responds back to the VM6 with an ARP reply. Um, so in TCAM, if there is a MAC IP binding is present, there is always a proxy reply from the VTEP, else there will be a broadcast. So now we'll see in detail when there are multiple VTEPs are present and how it leverages the EVPN fabric. So let's take in this example, the VM1 connected to VTEP1 sends an ARP request to obtain the MAC address of VM7. So the VTEP1, it creates an entry, suppression entry for VM1 and floods the ARP request to the VXLAN. Then VTEP2 and VTEP3 both receives the flood and de-encapsulates the ARP request and broadcasts the request to the local site. So VM7 sends an ARP response, in this case here, and VTEP2 creates a suppression entry for VM7 and forwards the ARP reply to VTEP1. So VTEP1 de-encapsulates again the ARP reply and forwards ARP reply to VM1, but it creates a suppression entry. And whatever suppression entries created here, the EVPN RT2 advertisement will share with VTEP1 and VTEP3 for VM7. Now, let's look at this topology. Let's say the L2 VLANs, which are represented in LO here, and VLANs with active gateway SVI are represented in blue, can be configured on these switches. So in this architecture, reachable neighbors directly connected in VSX environment will be synced between the primary and secondary VSX devices. And neighbors learned via EVPN route type 2 advertisements or EVPN VXLAN tunnel will also be synced. Also, the neighbors learned over static VXLAN tunnel will be synced. So let's talk about one of the use case here. So if there is a combination of L2 VLAN active gateway SVI and non-active gateway SVI for the same interface, then suppression entry would not be applicable to non-active gateway SVI. So what actually I mean, let me tell you with an example. For example, if interface 111 on switch 1 is configured with VLAN trunk and allowed VLAN 50, 60, and 70. So here, let's say the VLAN 50 is an L2 VLAN, and interface VLAN 60 is configured with IP address, and interface VLAN 70 has an IP address and active gateway configured. So there are three different VLANs here we are talking. So in this case, L2 VLAN 50 and active gateway SVI 70 would support ARP suppression extended, but the VLAN 60 would not support suppression because there is no SVI configured on it. Another example I can talk here is, let's say we have VLAN 80 and 90 configured on physical interface, for example, 113. And under the EVPN configuration, only VLAN 80 is defined and VLAN 90 doesn't have EVPN context. So with this configuration, both VLAN 80 and VLAN 90 ARP or ND packets will be stolen, even if VLAN 90 doesn't support suppression. There would be no suppression functionality for the VLAN 90 because we did not configure that under the EVPN, but NDMD module will do the reforwarding as required. And finally, configuration consistency is expected between the VSX devices. If there is an inconsistent config between the VSX pairs, then the behavior is undefined. So let's see some configuration and guidance here. So the basic configuration for the ARP suppression. In earlier pre-10.16, it is ARP suppression, just ARP suppression command, and for the IPv6 it is ND suppression. And with L2 VLAN support, it is ARP suppression extended for IPv4 and ND suppression extended for IPv6. And this is the configuration under EVPN that you just enable the ARP suppression and ND suppression extended. Some guidance here. So as we discussed, ARP suppression and ND suppression is used in conjunction with EVPN VLANs, and both are disabled by default. ARP suppression extended and ND suppression extended is mutually exclusive with ARP suppression and ND suppression respectively. What it means is if you have the ARP suppression configured under EVPN, you need to execute the no configuration command for the ARP suppression and then configure ARP suppression extended. It is either one of them. So the configuration consistency is expected between VSX devices. We've seen in the previous slide about that. So if there is an inconsistent config between VSX pairs, then the behavior is undefined. In centralized gateway topologies, in order to advertise L3 VTEPs, SVI IP and MAC redistribute local MAC IP should be configured so that the L3 VTEPs IP or MAC is learned on the L2 VTEPs. The active gateway MAC used along with IPv4 and IPv6 address must be the same on the given interface. It cannot be different. ARP suppression extender is not per VLAN configuration. So it's a global configuration command under the EVPN. So the configuration is applicable to all L2 VLANs and active gateway SVIs under the EVPN context. I would not say these caveats, but this is the behavior. So right now, ARP suppression is only supported for ARP packets received on access ports. Same thing with the ND suppression. ARP suppression, again, is not supported for ARP packets received on the VXLAN tunnel towards destination VTEP because it's already in the flooding state. Same thing with the ND suppression for IPv6. ARP suppression and ARP suppression extended at L3 will only work with any cased gateways configured, which we talked about the active gateway SVIs. The same thing is applicable for ND suppression and ND suppression extended. Also, ARP suppression extended will not work with proxy ARP enabled. Also, ARP protect is not supported with ARP suppression. So for verification and troubleshooting, I listed some of the show commands that you can use to verify that ARP suppression entry is created. And similarly, I listed some of the diagnostic commands here for you to check. We'll see in the following slides some of the examples. So the show commands show ARP VLAN 2. So here the PM, the host 11111 is local to the switch and 11112 is remote. So you see the entry is dynamic on the switch where it is learned, the suppression entry, but wherever it learned through remote VTEP, the source is EVPN. Same thing with show EVPN MAC IP. Here you can see 11111 is local, the flag is set to local, and 11112, you can see the flag is set to remote. And with show BGP L2 VPN EVPN command, you can see both the MAC and the IP address of the local host. The next hop here is its own VTEP. And the same thing with the remote host, where MAC address and IP address is learned, and with the VTEP gateway of the remote VTEP. You can see the local preference is 100 for both. This is defined in the BGP attributes to prefer these routes. So you can modify it and change it if you want to give a different preference with the BGP attributes. These are some of the diagnostic commands. As you can see here, the diag OVS DB dump table. This is for the remote L2 VPN neighbor. This is to check in the OVS DB that the entry is created through EVPN L3. And similarly for the whole neighbor table, you can check using this command. And you can see that 11111, this is on the side B. So you see 11111 is remote here, whereas 11112 is local in this case. So these are the entries created in the OVSDB. Let me show you a quick demo on this one. To show the topology that we're going to use for the demo before I show the CLI. This is a simple topology where there's no VSX configuration in this case. And I attached the configurations for the leaves. This is just to understand how the feature works in different scenarios with the different configuration commands. So here you can see leaf 1 on site A and leaf 1 on site B are connected to the spine switch. So you can add multiple switches here and do the VSX configuration. So scenario 1, we're going to discuss. On the leaf 1 site A, only L2 VLANs are configured, and on site B, it's L2 VLANs with active gateway SVI is configured. So scenario 1, we're going to see just the ARP suppression command is enabled on both the switches under EVPN context. Scenario 2, we have ARP suppression enabled on L3 VTEP and ARP suppression extended on the first one, first leaf. And in the third one, we have ARP suppression extended enabled across the leaves. So I'll go back to the demo now. So let's talk about the first scenario. And before that, you see the version, the switches are upgraded to 10.16 10.06 on all the leaves and spine. And you can see in the current configuration, ARP suppression is enabled on under EVPN context. And I cleared the ARP cache on all the switches. And then I initiated the communication between the VMs to see how it is learned. As you can see here, show EVPN MAC IP. You can see the remote IP and MAC address is learned because on the remote box, we have this active gateway SVIs, but on the local, you don't see the address because we have L2 VLANs and only ARP suppression is enabled here. Same thing with the show BGP L2 VPN EVPN command. You can see the IP address and MAC address is shown here, but only the MAC address shown for the local host. And you can also see the next hop VTEP here listed for both of them. So now going on to the leaf at site B, you can see a very similar behavior where the IP to the MAC mapping is listed in the show even EVPN MAC IP for the VLANs with active gateway SVI, but not for the one which it learned remotely, just the MAC address. Similarly, for the show BGP L2 VPN EVPN command, you can see the route type 2 learning has been done, and the MAC to IP mapping is listed here, but not the IP for the host connected to the VTEP one. Moving on to second scenario, where we have ARP suppression extended configured on the leaf 1 of the site A, and just the ARP suppression still on the leaf 2, where we have the active gateway SPIs. So I cleared the configuration again, the ARP cache again, and then I reinitiated the communication between VMs. Now you see in the show EVPN MAC IP, you can see both the local host to MAC IP to MAC mappings for both the local and remote are learned here. You can see the respective flags L and R for those entries. Same thing with show BGP L2 VPN EVPN command. You can see both MAC and IP are learned here, and then it's route type 2 advertisements for both of them. And even on leaf 1 on site B, you can see similar behavior. Now it can learn the host one from the first VTEP. And similarly, even in the BGP command, you can see host 1 and MAC address listed here. Now, moving on to the scenario 3, where we have ARP suppression extended configured under EVPN context on both the leaves. I cleared the ARP cache again between the VMs and then reinitiated the communication between them. So this is very similar to the behavior which we have seen in the second scenario, where it learns all the entries of both the local host and remote host, and respective flags are shown with the show EVPN MAC IP. Same thing with the show BGP L2 VPN EVPN2. You can see all the route type 2 entries and internal IBGP entries are created here for both the hosts. Additionally, show ARP VLAN 2, you can see the local entry is called dynamic, which we discussed earlier, and the one with learned remote host is the EVPN. Same thing, as you can see here on the second leaf 2, we configured the ARP suppression extended. And both the entries are created for both of them, because ARP suppression extended includes the ARP suppression and the ARP suppression extended for the L2 VLANs. So there will not be any change in how it learns on the second leaf. Same thing with the show BGP L2 VPN, L2 VPN EVPN command. You can see both the route type 2 entries created here. We'll see diagnostic commands here. The remote L2 VPN neighbor table is part of the OVS-DB diagnostic output on HPE Aruba CX switches. So it provides visibility into remote layer 2 VPN neighbors. It's typically learned via EVPN VXLAN and includes details about MAC IP bindings, tunnel endpoints, and how the switch sees remote hosts. And even the neighbor table in OVS-DB diagnostic dump provides detailed information about learned neighbors in the VXLAN EVPN fabric. These entries represent MAC IP bindings, tunnel endpoints, and forwarding state for both local and remote hosts. So these commands, the diagnostic commands, are useful to help verify EVPN MAC IP learnings, useful for troubleshooting reachability and host mobility. And also, these commands confirms that the remote endpoints are properly learned and associated with the VXLAN tunnels. Encouraged to join in the AirHacks community to post any questions.